In this video, I want to talk about clean code, and I want to talk about well-organized Unity projects. So up until this point on your midterm projects, I have not really cared about your code quality and your Unity organization. Occasionally, it'll come up in one-on-one meetings, and I'll point out some things that could be improved, but by and large, I'm more focused on the idea and you being able to express it in terms of code, so getting to a complete game. But now that we're moving into the last milestone, we actually need to start caring about quality. So you are essentially delivering a final product, and in most places in the real world, that means that you're going to have to do this kind of code quality and organization check on your project. So if you're pursuing a career in game programming or in programming, or you're working in game development, these are things that you'll have to do. And especially any place where you're working on a team, it's really important to make sure that your project is well organized and your code is clear so that you can actually collaborate on the project with other people. For our section of game engine scripting, I have this game engine scripting style guide that's linked from the canvas. Go through this. There are a lot of rules in here, but it is not a super long style guide. It's just focused on the big key things that are important for us to work on in game engine scripting. And we're going to go through this step by step and look at this project that I have for you here. It is a project from a past year, and I have two scenes. Essentially, I have the dirty scene that is just absolutely horrible. I have tried to make it really hard to read. And then I have a clean scene that has much more well-structured code that applies the principles from the style guide. And so if you haven't already, be sure to download the project linked from Canvas, go through the dirty one, go through the experience of looking at someone else's poorly structured code and see how hard it is to read poorly structured code. And then come back here, unpause the video, and watch me walk through and point out some of the things in the dirty version that could really be improved in the clean version. Okay, I'm trusting that you did that. So let's take a look at this dirty version versus the clean version. Without even touching the code, let's just look at the Unity window here. So hopefully this is giving you some anxiety looking at my hierarchy over here, because it's impossible to tell what anything is in this scene, and it is not well organized. And so this Unity style guide, the last two here, scene organization and folder organization, apply not even at the code level, but just to our scenes. So if you are creating a scene in Unity, make sure you're using descriptive and accurate names for the objects in your scene and for your scenes themselves. Here, clearly these are not well described names. So like this is an asteroid and it's just called Game Object 6, another one that's called Game Object 10. It's pretty impossible to tell where even like the player is in this hierarchy. Game Object 12 is our basketball scene. So names here are awful. The other thing that's kind of missing from this is that you can use empties to organize your scene into logical groups like lights, building, player, etc. So if we come back here and we flip from the dirty scene to the clean scene, here all of the objects are well named. I can see where the player is, I can see where the basketball court is, and then I've used empty game objects. So this asteroid field is just an empty game object that has a bunch of asteroids within it. And same thing, I have this invisible walls object that has a couple invisible walls in it that are all named wall. So already by doing that, we've made a massive improvement to how legible this scene is to another person who has to jump into the project, or even to ourselves. Like imagine that we have to open this project up in a month. If you're faced with looking at this, where do you even start to think about adding things to this project? As opposed to this clean demo, it's a little bit more clear what everything is. It's easier to find your way around. So that's the Unity scene level. Let's dig into the code. And so I'm going to flip back to our style guide here. And there are kind of two golden rules that we want to keep in mind across everything. So one is that you want to favor clarity in your code. Code is a thing that's meant to be read and is often a collaboratively produced artifact, which means that you're working with other people who have to read your code, or you're working with yourself in the future where you have to open the project a month later and add a new feature. And so everything that you do to make your code more clear will pay off dividends in terms of being able to produce things in the future or having teammates be able to work effectively in your code base. Second is that you should use a consistent set of style conventions when writing your code. So if you use a different naming convention for every variable, some of them are all uppercase, some of them are lowercase, some have a bunch of underscores between them, and there's no rhyme or reason, it makes it really hard for anyone to read your code and sort of identify the patterns in your code. So that's why we use style guides like this to guide us when we're writing our code so that we can make sure that everything is written consistently. So with those in mind, let us jump back into Unity and start looking at some of the C# code. Let's flip over to the dirty scene, and we're going to go through a couple of the scripts here. There are 3 in the dirty scene, and we're going to start with Buddy. Flip over, take a look at Buddy, take it in all of its horrible glory. This should be pretty unreadable to you, hopefully. And hopefully your brain is screaming about certain things that we're seeing in here, and we're going to pick them apart one at a time. So right off the bat, we're seeing something that kind of violates our use consistent style conventions when writing your code, is that this is all over the place in terms of spacing. We see some brackets that are all the way over here, violating kind of the nesting indentation rule. We have spacing that's just like wildly inconsistent. This line is here, this line starts a tab over, this one starts 2 tabs over, there's a whole bunch of white space here. So actually, to fix some of the spacing, what we can do is use Visual Studio, the format document, Control-K, Control-D command, which will fix at least a touch of the spacing and at least allow us to highlight one of the other rules here is under brace style. We want to make sure that we're using this style of brackets where the bracket starts on the next line after classes, methods, if statements, and that we respect indentation. So before, just Control Z, here we're not respecting that indentation. This would also be bad if we put the bracket up here. We want to make sure that we're using consistent styling. So format document, save this. We made a little bit of an improvement. The next thing that I want to focus in on for fixing this is naming conventions. So bringing up our style guide here. Naming is really, really important to code because a lot of what you do involves creating new classes, creating new variables, creating new methods, and each of those has to be named. And so here I have linked to Microsoft's naming convention and capitalization guide. This guide generally follows that with 1 or 2 exceptions to kind of match how Unity does their tutorials. But a few things here, we want to make sure that our variable names, our name choices are clear and readable. We're clearly violating that. We've got just a variable called B. We've got a variable called time, which doesn't really tell us anything, and shoot, that again it's not a terribly descriptive name. And we want to make sure that our classes, fields, properties are all generally named nouns, our methods are named verbs, and our Boolean variables are named something like is invulnerable or has key. And then specifically, we want to make sure that our casing is consistent in our project. So by and large, we're going to use Pascal case for classes, methods, properties, and then we're going to use camel case for fields, parameters, and local variables. And there's an example here that's pretty similar to what we have in the code that demos all of those things. But let's take a look at what is being violated in our specific code here. So One is we're not using descriptive names. So this name here, B, if we peek into the clean code for a quick second, is supposed to be something like ball prefab. That's the ball that is being instantiated here inside of this script whenever the mouse button is down to actually fire. So we can rename this using the hotkey in Visual Studio, which is Control-RR, and we can say ball prefab and hit enter. And we're using our convention of this is a field, so it's going to be camel case. So time, again, we're going to kind of peek into the clean code. Time is something like shots per second, how many times the player can shoot a second. And so time violates our descriptive rule and also violates the camel case rule. So Control-RR, let's call that shots per second. And shoot, this is a Boolean variable that's controlling whether or not the player is currently able to shoot. And so like we saw with our style guide here, we kind of want to have these variables that are Booleans framed as a question to make them clear. So in this case, we could rename this to can shoot. All right, great. It's starting to come together. Things are looking a little bit more clear. Staying at the top of our file here, hopefully you see something that also violates one of the rules that we've had in class. All of these are public. So public means that anyone in our code base could reach in and manipulate these variables, which doesn't really make sense. There's no reason for code to reach in and change our ball prefab in our game. We're always spawning in the same basketball, so there's really no reason for this. And what we generally want to do when we're writing our code is start with private as the default for everything. And then when things need to be opened up to be more accessible, then we can do that when we have the proper justifications. So public would be if we needed something to be able to reach in and access or manipulate the shots per second. Like if a power-up was picked up that made it so that the player could shoot many times, maybe there would be another script that's our power-up that can reach in and manipulate this field. And then we might consider making it public. But if all we're trying to do is make the variable show up in the inspector, instead of making it public, this should be a serialized field. So these rules are also in the style guide. If we scroll down here, access level modifier, default to making everything private, use a serialized field to expose things in the editor, don't use public. The next one I want to talk about has to do with using descriptive names, but is a little bit harder to capture in a rule. So this kind of falls under our general rule of favoring clarity in our code. So if we come back to this script, let's fix this white space and get all of this on one line. This code is not terribly readable. We have a game object that's being instantiated. That's okay. We've got something called RB. We're adding a force. It's this like Euler direction times forward times 20. Maybe I'm not really sure exactly what that is. So I think we could improve our script so far. So I'm going to recommend that we make this a little bit more explicit. We can say this is the ball rigid body and game object. We could also make this more descriptive and call this the ball. And this line of code here is a lot to fit in to one line. So let's pull this out. And I happen to know that this is the shoot direction. So this is the direction that we're trying to, this quaternion Euler, the rotation of 15 degrees in the z direction times the forward direction. That is the shoot direction, where we want to throw the ball. So we can grab that and use this times 20 to kind of clean this up. So now it's a little bit more clear. We're calculating where we want to throw the ball, and then we are scaling that. We're adding this force, 20 units of force to apply that. So this is better, but there is something that's a little inflexible and confusing about our code. And that brings up this principle of magic numbers. So in programming, when we have a bunch of values like constants in our code base that don't really have good explained meanings, we think of those as magic numbers. So if you just encountered a line of code that was health minus equals 5, it's like, what does 5 mean? Why 5? And in those places, we want to prefer variables or even serialized fields for those things. So in this case, health minus equals attack damage is much more clear about what the intent of the code is than health minus equals 5. So this is going to make your code more readable, and it's also going to make it more flexible if we use serialized fields, because now we've exposed those fields in the inspector and we can kind of tweak them so that we can find the perfect values for, say, attack damage. Or in our case, if we flip back to the code, we have a couple magic numbers. We have this 15 here, and we have this 20 here. And so the 15 is when we're throwing the ball, how much arc do we put on the ball when we're throwing it? And the 20 here is how much force are we applying when we throw the ball? And both of those might be things that our designers need to tweak as we are experimenting with finding the right values that makes the game feel great. So let's pull both of these magic numbers out into serialized fields. We're going to call this one the upward shoot force tilt, and we could default it to 15. Serialize field, private float. This is the shoot force, and we can default that to 20. So now both of these should be tweakable in the inspector, but they've also had the advantage of making our code more clear. So if someone's coming along and reading this, instead of seeing just the number 15 and having to think about like what does quaternion.euler mean in this case, it's a little bit more clear because we're using English in place of 15. So this is the upward shoot force tilt, and same thing here. Shoot direction times shoot force is relatively clear if you have an idea of how vectors work. We're taking a direction and we're scaling it by a force, as opposed to shoot direction times 20, a little less clear. Before we leave this file, I see two more things that we should probably fix. One is there's still a couple naming things, like this is called shooter for some reason, but really what this does is enable shooting. So this method should probably be called something a bit more descriptive and should be in our Pascal case convention. And then the script up here is also called buddy, which really does not describe at all what this script does. So this would be better as like shoot or player shoot. And we would need to make sure that we also rename that file to match. And the last thing in this script that we want to think about is that we have this logic here, which looks like it's taking the mouse X and mouse Y and rotating the player so that you're able to line up a shot. And that isn't inherently tied to our logic here, which is around shooting the ball when the player clicks the left mouse button. And so when you're thinking about your scripts and thinking about good organization, you kind of want to divide up your scripts into as modular pieces as you can when those things are independent. So in this case, we have two features that really should be separate, something that has to do with mouse look and something that has to do with shoot. And so this logic shouldn't even be in this script. I'm going to get rid of it. At this point, we've actually covered most of this style guide in just looking at this one script. But let's take a look at one or two more. So we've got a hoop script here. Let's look at the hoop script. So I'm going to close down player shoot, and we have the dirty version of the hoop script here, which a couple things may jump out at you when you're looking at this. Hopefully the most salient one is that it looks like we have some code that is commented out for some reason, and we have some code that is grayed out. And so Visual Studio is going to do its best to look at the variables that you have and try and check whether they're used anywhere. And if they're not used anywhere, they'll be displayed in a dimmed out text. So that brings me to this rule of removing unused code. So in general, you want to keep your scripts as tidy as possible. So if you have unused methods from the Unity template, like an empty start method or an empty update method, cut those out of your scripts. You should remove commented out code. There isn't a good reason for us to have code like this that is just dead and dormant sitting in our code base, especially if we're using version control, where we still have our history from our past commits. And if this was the way we did something previously that we want to be able to go back to, we can just hop back in time to that past commit. We don't have to leave commented code out in our code base. And then also remove any unused variables or methods. So if we have variables like this, or we have fields, or we have methods that we're no longer using, again, cut those from your code base. And same deal, since all of this is in version control, we're making commits regularly, it's fine that we cut those and commit them. If we need to go back, it's in the history. We can always go back to that commit and pull it back out. I think for this one, rather than go through step by step fixing all of this, let's just pull up the clean code side by side. So again, we have a script naming thing. Hoop is not terribly descriptive for what the script does. Renamed it over here to hoop mover to make it specific. We have a couple magic numbers that were baked into our code here. So we had something on line 16, which was just the number 2 for the speed for how quickly this hoop moves around. And we had the way the hoop moves is it picks a random target every so often, and we had sort of hard-coded this here to be -2.5 to 2.5. So just pulling those out into fields, removing those magic numbers can be really helpful, and by making them serialized, we can tweak them in the inspector and try and get to the best feeling gameplay. We had some variables down here that got changed. So the underscore position breaks our naming rule. So using something like pos or position would be better over here. Inside of our update, we had a bunch of unused code that could just be completely cut out. And then the trimmed down version, it also is useful to add comments throughout your code base to explain why you're doing something in your code. So this is saying we're taking a small step from the current position to the target position each frame. And then the code has been cleaned up by having variables in place of just magic numbers. So let's do the same for the last script in the dirty scene. So we've got a goals script. Let's close that and let's grab the clean version, which is score manager. We're just seeing the same principles again. Name your scripts well. So score manager is a better name than goal. Name your fields well. Score text is better than T. S score is better than S, etc. So I will make this dirty and clean code available to you so you can sit down and look at it, I would encourage you to take the dirty project and try and clean it up yourself, and make sure that you keep this style guide handy as you're working on your final milestone for your midterm. Go through this, use it as a checklist, think about your naming, go through your scripts. Are you actually writing clear and readable code, or do you have a bunch of abbreviations in your code that make it really hard to read? Are your classes, fields, names, are they descriptive nouns, or did you use a verb someplace when you were defining a variable? Are your brace styles consistent? Did you use private in places where it should be private? Did you avoid magic numbers? Just use this as your checklist before submitting your final code to me.